Hey guys, I have your notes here for section 5.2 day 2. And so on 5.2 day 1, what you did was basically just found sine, cosine, and tangent for angles that weren't common angles, but could be written as the sum or difference of some common angles. So you just did sine, cosine, and tangent on some of those angles using those formulas. Well, today, we're still going to use these formulas. These are the same formulas that I had yesterday. I've highlighted them the exact same way. Today, we're going to, kind of do some weird stuff with these formulas. We just got to kind of follow, pay attention to the directions. So, on the first example, it says that we're supposed to verify the identity. And I know there were some people that said, please, 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 Ms. Neal, don't ever make me do trig proofs again. Well, here's just a little bit of trig proofs that you're going to have to do. But they aren't as bad as the ones you did back in the last chapter, I promise. It's saying prove that sine of this is equal to just simply the cosine of this. So I'm going to use one of my formulas. I recognize this as, I can use a difference formula here. This is my first angle, this is my second angle. Don't let the fact that my second angle has an x in that spot confuse you. Because when you look at the formula, x is in the first spot. So I'm going to kind of ignore the fact that there's an x here. I'm just going to call this my first one and my second one. I'm going to follow the formula. So the formula says, do sine of your first one times cosine of the second, whatever that may be, minus cosine of the first one times sine of the second one. And then all of that is supposed to equal cosine of x. Now let's do some of the math that we are able to do. So sine of 90 degrees, let's see, sine of 90 degrees is 1. And that just stays cosine x, nothing I can do there. Minus cosine of 90 is 0. Sine x stays there. Multiply these two, they're gone. Basically what I get is cosine x on the left matches cosine x on the right. Look how easy that trig proof was. Next one. We're supposed to simplify this as much as we can. We're not going to get an exact answer, like a value, because there's an x in it. Just do what you can and simplify it as much as possible is what we're going to do. So I see this as a sum formula. This is my first angle. This is my second angle. I'm going to use the formula. Here's what it looks like. Sine of the first times cosine of the second minus cosine of the first times sine of the second. Let's see what we can do with this. Sine of x is just going to say sine of x. Cosine of 3 pi. 0, 1 pi, 2 pi, 3 pi. So cosine of 3 pi is the same as cosine of pi. So that's negative 1. Minus stays. Sine of 3 pi is the same as sine of pi, which is 0. So multiply and I get negative sine x. I've simplified it. Turns out sine of this plus this is just negative sine fraction of x. I just simplified as much as possible. Whew, okay, these are fun. Solve it. We're solving an equation. So in my equation, there's an x. There's an x. All this is supposed to equal 1. So when it's all said and done, my answer should look like x equals. Maybe 1 answer, maybe 2 answers, maybe 4 answers, who knows? My answers are going to be x equals. So I recognize this as cosine sum and cosine difference. So don't write too big because we're going to have to sub in these into a cosine sum formula, which looks like, let's see, the cosine sum is cosine minus sine. And then we're going to have to sub these in the cosine difference formula, which is cosine plus sine. Here's what it looks like. Here's the first one, cosine of the first, cosine of the second, minus sine of the first, sine of the second, minus. This is going to be a bunch of stuff. put parentheses around the whole thing. I put brackets, whatever. So the cosine difference, we're going to cosine of the first, cosine of the second, plus sine of first, sine of second. Close off your parentheses or brackets, whatever, and that's supposed to equal 1. Do any math that you can. Cosine x, wrote it down, times. Ooh, I know this. It's radical 2 over 2. Minus. Sine of x, write it down. Sine of pi over 4. Ooh, I know this. It's radical 2 over 2. Minus, parentheses, bracket, whatever. Cosine x, write it down. Cosine pi over 4. I know this. Sine pi over 4. I know this. It's still supposed to equal 1. Now, I'm going to distribute this negative into the parentheses and something else I'm going to do. All of these radical 2 over 2's that's being multiplied here, I'm going to go ahead and put it out in the front as if it were a coefficient of my trig. So instead of having the radical 2 over 2 at the end, I'm going to put it in front of each trig expression. So I distributed my negative, and now look, all my radical 2 over 2's are in the front. I just think it's gonna make more sense to you that way. Now let's see, are there any like terms that we can collect here? Like terms, I got radical 2 over 2 cosine x and negative radical 2 over 2 cosine x. Ooh, those add together and cancel each other out. So I'm left with this term, which is negative, this term, which is negative, and a 1 over there. Now, listen, ready? Negative 1 radical 2 over 2 sine x minus another radical 2 over 2 sine x. Combine those. We get negative 2 of those over 2. Negative 2 of those over 2. So since they both had a sine x, they both had a radical 2, and an over 2, they had a common denominator, I basically combined these and I got this. These cancel. Divide both sides to get your trig expression by itself. Divide both sides by my coefficient. And look what I get. Over here I get 1 over negative radical 2. We're going to have to fix that. Fix it. I get radical 2 over 2. Now you know how to do this. You know how to do this because of the section that we just got through working. So I'm going to go reference angle for radical 2 over 2 is pi over 4. My fraction is negative. I'm in quadrants 3 and 4. Thus, my answers are first angle is in quadrant 3. Second angle is in quadrant 4. And that's a 7. That looks weird. That's a 7 pi over 4. Alrighty. Last one. The first thing I did was just kind of wrote down some information. So it said find the exact value of this. And this kind of triggered a memory. It's like, oh, I think there's a formula for that. So I just copied this down and put it in its formula. Okay? And then I wrote down that my sine of x, which happens to also, there's an x here and here. Sine of x is this. It gave that to me. And it also gave me cosine of y is 15 over 17. So, let's see if I can figure this out by subbing in stuff that I know. Here I go. Cosine x. Do I have cosine x? Do I have cosine x? Oh, dang, I don't have cosine x. How about cosine y? Do I have cosine y? Oh, good, I have cosine y. How about sine x? Do I have sine x? Yep, I have sine x. Do I have sine y? Nope, I don't have sine y. So I have 2 of the 4 pieces that I need to sub in here. But here's the cool thing. with these two pieces that I have, I can find the other missing pieces. What's missing? I'm missing a cosine for this angle, and I'm missing a sine for this angle. We can find those. Watch. Here's what I know. Sine of some angle is -3/5. So, sketch a little right triangle, put your angle there. Sine is opposite over hypotenuse. I wonder what that side is. Pythagorean theorem will tell you it's 4. Now, what's your cosine fraction for that angle? Adjacent over hypotenuse. But I wonder if it's supposed to be positive or negative. Hold that thought. Let's do the other one. Let's do an angle called y. This is what I know. Cosine for y is 15/17. So I drew a right triangle. Here's y. Cosine is adjacent over hypotenuse. That's supposed to be a 15. That's very sloppy. Pythagorean theorem will tell me this is 8. So my sine fraction for y is opposite 8/17. I wonder if it's supposed to be positive or negative. Go back up to the problem. We missed something. Both x and y are in quadrant 4. If this is in quadrant 4, what would you like for that fraction to be, positive or negative? If this is in quadrant 4, what would you like this fraction to be, positive or negative? Now, I have all 4 pieces that I need. Let's do this again. I just literally copied and pasted this up there, down to below. Cosine of x, I have it, it's right there. Cosine of y, I have it. It's right there. Sine of x, I have it. It's right there. Sine of y, I have it. It's right there. Sub them all in. Sub them all in. These two ended up being negative. Multiply straight across the top, straight across the bottom. They already have a common denominator. I added them together, and I got 84/85. That was fun. All right. Good luck with this.